All right. I think this is for Evan and maybe whoever else is gone for section 8.3. These are special right triangles. I'm going to do a run through though of what we did in section 8.2 though, just to kind of like refresh our brain because there was, 2 days off for a weekend. We talked about Pythagorean triples in the last section, like basically sides that you can put together that come out perfectly in the Pythagorean theorem. Do you remember what those were?
3, 4, 5.
3, 4, 5 is one of them. That's one that you should have memorized. Now, 3, 4, 5, are the sides of a triangle, right? So 3, 4, 5 is the hypotenuse. Those come out. A squared, B squared, C squared comes out perfectly, right? Okay. Now, in addition to 3, 4, 5, if you have 6, 8, 10, that is also a 3, 4, 5. We know that, right? Because you're just multiplying it by 2. Okay, what's the other one that I told you that you should have memorized? 3, 4, 5, and yes, there's one with the 12. You remember what it was?
12, 13.
5, 12, 13. Those are the two that you should have memorized because they show up on the ACT a lot.
9, 40, 41.
9, 40, 41. Okay, so those are the two main ones. 9, 40, 41 is one that shows up sometimes. You won't see it very often. There's another one that starts with a 7 and another one that starts with an 8.
7, 24, 25.
7, 24, 25. She's cheating.
I am cheating.
That's okay. We don't care. It's fine. 8,
15, 17.
15, 17. Okay, those are ones that come out really nicely. Those are like 5 of the main ones. Really, the top 2 are ones that you should have memorized if you're going to do like ACT type of stuff because they will embed those in to places. They might do like the 6, 8, 10 thing, but if you can recognize those as special right triangles, it will save you tons of time. Tons of time, okay? Now we're going to talk about different special triangles, which are a 45, 45, 90, and a 30, 60, 90, okay? So here's what I want you to do. This is going to be your cheat sheet. Write these at the top of your paper, and then we will label them, and I'll show you kind of how these work, okay? So put those at the top of your paper, and then we'll label. I'll give you a second to do that. All right, are we good to go? Kinda, maybe? We're going to start with 45, 45, 90. We'll do a couple examples of that, and then we'll come back up to the top to fill in the 30, 60, 90. So here's the deal. For a 45, 45, 90, when we're talking about the sides, so we're talking about like this side versus this side versus this side, okay? We know already that like this side here should be exactly the same as this side right here, right? Like the opposite thing, like we crisscross their isosceles triangles. Those two sides should be the same, okay? Now, this third side, that hypotenuse side, will always be in a certain relationship to the other two. And I'll show you what that relationship here is here in a second. But to kind of illustrate this, what I do is I like to make this guy into a box. Okay? And if we kind of make this into a box, like I can pick any side lengths that I want to for that box. But I'm going to pick like the most basic number, and I'm going to make them all a length of 1 all the way around. All length of 1. So we have our 45, 45, 90 triangle has legs that are each 1 unit long, right? They're 1 unit long. If I'm trying to find the length of the hypotenuse, I would do 1 squared plus 1 squared equals, we'll call that my C. This guy's my C value. C squared, all right? 1 squared is 1, 1 squared is 1, 1 plus 1 is 2, so 2 equals C squared, and C will end up being the square root of 2. All right, when we do this homework assignment, you will not have any decimals in your answers. Yay. Kinda, maybe. You won't think yay here in a minute. All right, but so here's the deal. Whenever you have a 45, 45, 90 triangle, all of the sides will be in the relationship of 1, 1, and square root of 2. Embed that in your brain, 1, 1, square root of 2. That's what a 45, 45, 90 triangle looks like. Now, they will make your triangle like bigger dimensions than 1, 1 square root of 2, but if you know 1, 1 square root of 2, it will make it easier for you to solve for any of the other sides, okay? Now, before we move on and actually do a problem, let's look at what number is in front of the square root of 2. 1, right? There's no number, so it's like 1 square root of 2, okay? So keep that in mind as you go through here. So here's the deal. Whatever this side is, this side will be the same, right? And this side will just be the same as this one, but multiplied by the square root of 2. Does that make sense? We're just taking this length right here, multiplying it by the square root of 2 to get the other one, right? Okay. Now, what if they give me this one? How do I go back to this side?
Divide it.
Divide by a square root of 2, right? So that's kind of the trick there, is that if you are finding hypotenuse, to find the hypotenuse, you take the leg and you multiply by the square root of 2. If you're doing the opposite one, if you're trying to find the leg, you take the hypotenuse and you divide by the square root of 2. That's kind of how it works, right? So any 45, 45, 90 triangle, if you're trying to find a leg or a side or a hypotenuse, you just do the square root of 2, right? Okay. And Chase this morning was like, how do I know which one is which, right? How do I know whether I'm multiplying by the square root of 2 or dividing by the square root of 2? Okay. That's a good question. Let's say I have one of these sides, right? I'm going to get rid of all my nasty stuff here. Let's say I have this side right here, and I'm trying to find the hypotenuse. I don't know what that is. Is the hypotenuse bigger or smaller than the leg? Bigger. So you're going to have to, which one? Multiply or divide to get it to be bigger? Multiply. I'm going to have to multiply by the square root of 2. So it depends on whether you're going from smaller to bigger, bigger to smaller. Okay. Let's do an example. Let's do right here. Okay. A, this is a 45, 45, 90 triangle. This leg is 6. They don't have this labeled, but the other leg is also going to be 6, right? If I'm trying to find the hypotenuse, all I need to do is to go from here to here. I just multiply by the square root of 2. What is 6 times the square root of 2? Don't do it as a decimal. 6 square roots of 2. That's all it is, right? So if it's 6 at each side is 6, it's 6, 6, and 6 square roots of 2. That's what the hypotenuse will be. You're just multiplying by the square root of 2. Not too bad, right? And you'll leave your answer like that. Don't put it as a decimal, right? That's what it will look like. Okay, now, in part B, they give you the 2 legs, right? They're both 9 square roots of 2. And how do I find the hypotenuse from that? You still are going to multiply by the square root of 2, right? Okay, so here's the deal. This gets people confused. We're taking 9 square roots of 2, and we're multiplying by another square root of 2. Are we doing okay so far? Mm-hmm. Okay, do you know what the square root of 2 times the square root of 2 is? It's like the square root of 2 squared. What happens with the square root and a square?
It's just 2.
It cancels out. So anytime you take the square root of something times itself, it just comes out of the square root. So this is just 9 times 2. These guys, the square root of 2 times the square root of 2 is just 2, right? Okay. If you have the square root of 3 times the square root of 3, it is just 3, right? Like you could write it as the square root of 9, right? Which is just 3. What about like the square root of 12 times the square root of 12? It's just 12, right? Anytime you take a square root times itself, it just pops out of the square root because it's like the square root squared and it goes away. So this is really 9 times 2, which is 18. So this side is going to be 18. Make sense? So you're taking it and multiplying it by the square root of 2. Make sense? Good? Okay, now let's go down and do the next one, and then we'll go back and go to a 30, 60, 90 triangle. This one's probably the hardest. Now they're giving us the hypotenuse, and we're trying to find one of the legs, right? Okay, how do you go from hypotenuse to leg? Divide by the square root of 2, right? Okay, so here's what this looks like. 12 divided by the square root of 2 is like 12 over the square root of 2 as a fraction, right? Okay, now the problem is we never leave square roots in the bottom. Okay, we did this briefly in algebra, and this process is called rationalizing. Rationalize. And it's not too bad. You get so used to doing this that you can do this in your head. Probably. Okay? We are rationalizing. Okay? So we want to rationalize. We want to get the square root of 2 out of the bottom. So here's how this works. Every single time, we're going to multiply by. The thing that I don't like is the square root of 2. So I'm going to multiply him by the square root of 2. Because what's the square root of 2 times the square root of 2? That's just going to give me 2 on the bottom. But if I multiply by the square root of 2 on the bottom, I have to multiply by the square root of 2 on the top also. Does that make sense? Okay, so we said that the square root of 2 times the square root of 2 is 2 on the bottom. What's 12 times the square root of 2? 12 square roots of 2, right? Okay, but we're not quite done yet because at this point, these two can reduce, right? 12 and 2 becomes 6 square roots of 2. Okay? That's what each one of these legs is 6 square roots of 2. 6 square roots of 2. Does that make sense?
A little bit, yeah.
Yeah. Now, this rationalized step, I want to talk about him for just a second, okay? 12 over the square root of 2, we're taking it times the square root of 2 over the square root of 2. If I reduce the square root of 2 over the square root of 2, what does that become? Square root of 2 divided by the square root of 2 is 1, right? So I'm taking 12 over the square root of 2 times 1, which means I'm not doing anything to it. I'm not changing its value. I'm not changing the value of it. I'm just changing what it looks like. Does that make sense? Right? I'm just multiplying it by 1, basically, right? So I'm just changing what it looks like to make it so that we don't have that square root in the bottom. So it makes it a little bit nicer, right? So 6 over the square root of 2. What?
Why don't you like it on the bottom?
Because it's considered to be like improper. It's kind of like the same thing as changing it from an improper fraction to a mixed number. Sometimes like it's considered to be not correct. Okay, now there is kind of a little trick. Luke noticed this right away this morning, and he said, okay, if you're looking at your hypotenuse and it's a whole number, check this out. Your hypotenuse is a whole number. The sides are just going to be half of that, and then tack on a square root of 2, right? So like, let's say you have the same thing again, right? And let's say that this is 50. What are each one of these guys going to be? 25 square roots of 2, right? That's what each one of those is going to be. 25 square roots of 2. That's kind of what that looks like. What?
That's easier than running up.
Right, right. If this is a whole number. Now, let me do this to you. Haha. Let's do this. Let's say that this number is 11 square roots of 2. What will each one of these sides be? How do you go from here to here?
Oh, you just,
You divide by a square root of 2. So this is 11 square roots of 2 divided by square root of 2,
So you just take off the root.
which is going to cross those off. So each one of these is 11. Does that make sense? So if it's a whole number, you half it and attach the square root of 2. If it's a square root of 2 number, you just take off the square root. Does that make sense? Right?
just taught us that first.
I know.
Yeah, you should've just taught
I
us this
know.
very
Isn't that nice? So anyway, but you have to be careful, because if you're going from the sides to the hypotenuse, you're multiplying by the square root of 2. Okay? But if you're going from hypotenuse to side, you divide by square root of 2. Are we utterly confused yet? Or no? Not too bad? Okay. All right. Now, 30, 60, 90 is a little bit more involved just because you have different sides, right? Like we don't have two sides that are the same. So we've got a little bit different of a story up here. So go back up to the very, very top, and I'm going to show you what this guy looks like. And I have a mess. So I don't use my lasso tool very often. Oh, that's not working. That's not my lasso tool. Is that? No?
No.
How do I lasso it? Ha, there we go. I'm going to move him over. Ha ha. I know. I don't do that very often, but anyway. Yep. So there we go. All right. So we have a 30, 60, 90 triangle. There you go. Ready? This is what I do. I make him into, and they were like yelling at me this morning, you make him into a rectangle. No, you don't. I make him into one of these. What is this?
I don't have room to do that.
A bigger triangle. It's fine. It's an equilateral triangle. It's an equilateral triangle. All right.
Darn it, I don't have
Just to figure out what your labels are. It's fine. It's fine.
If only I could do my
You don't necessarily have to write this in here. I'm just showing you like how these numbers magically come about.
Definitely not an equilateral, but
I know mine doesn't look great, but anyway. Okay, so this is my equilateral triangle. Ready? Okay, now here's what I could do. In my equilateral triangle, if we're talking about these sides, like this side and this side and this side, we could call them all 1. 1, 1, 1. Okay, don't write that down. Don't write it down. Don't write it down. Because I'm going to change it here in a second. We could call them all 1, right? We could call them all 1. But then, if I'm looking at just the green triangle, what would that guy be? Just that bottom side. Half, right? I don't want to have to deal with halves. So what we're going to do is we're going to call each one of these 2 and 2 and 2. And so this bottom side right here is 1.
you can write that down.
Now you're going to write that down. Okay? So each one of those big sides is going to be 2. And then this bottom side of the green one is going to be 1. Okay? All right, now, if we're just looking at this green one right here, just this green triangle, because that's my 30, 60, 90 triangle, we know that the short side is going to be 1, right? The hypotenuse side, not the tall side, the hypotenuse side is going to be double what that is, right? Okay, so this side is 13. This side is going to be 26. It's just double what that other one is, right? If it's a 30, 60, 90, the short side will be half of what the hypotenuse side is, or the hypotenuse is double the short side, right? This side right here, we can solve using the Pythagorean theorem, right? Okay, so let me show you. This side, we have a squared plus b squared equals c squared. Which side is the side c?
It doesn't really. Oh, it's the hypotenuse.
The 2, right? The 2. So let's call this side b, right? 1 squared plus b squared equals 2 squared, all right? 1 squared is 1, 2 squared is 4, and then we subtract the 1 over. So b squared equals like 3. So what's that side going to be? The square root of 3. So my sides for a 30, 60, 90 are 1, 2, and square root of 3. The square root of 3 is the tall side, right? We have a short side, a tall side, and then a hypotenuse side, right? I know, that's just what I call them. So your short side will be 1, your hypotenuse side will be double that, and your square root of 3 will be your tall side. Now, keep in mind that there's a 1 in front of that square root of 3, okay? So, let's say that your short side is 7. What will this side be? 14. What will this side be? 7 square roots of 3, right? Does that make sense? Okay. So, kind of in the same way as you had your square root of 2 thing, if you're trying to go from this guy to this guy, you multiply by the square root of 3. If you're trying to go from the tall side to the short side, you divide by the square root of 3, right? That's kind of the relationship that works, all right? So should I write out a little key code that has little stars there? I'm going to say tall side equals the short times the square root of 3. Your short side equals the tall side divided by the square root of 3. Okay? Now let's talk about the hypotenuse side. What can we say about the hypotenuse side?
It's double of the short.
It's the short times 2, right? It's double the hypotenuse side. I'm going to make that 2 a little bit better. Okay? So there's your little code there of how you can get to those numbers, right? Okay, 1, 2, square root of 3 is your relationship, yeah? Okay? Yeah, we're going to skip the problem in the back, but we'll do the ones down below. Okay, did you get that all written down?
Yeah.
Woo, lots of information, but it kind of makes sense, right? Like how you do all these. Okay, so let's go down and do this one. Let's do this guy. Okay, so which side is my 1 side? The top one, the X, right? Which one is my 2 side?
No, y.
Y, the hypotenuse is my 2 side. The square root of 3 is this guy, okay? So, if I'm given 15 and I'm trying to get the 1 side, what do I do with that 15?
What again?
I have the 15 side.
Divided by.
You divide by the square root of 3. I'm either going to take that tall side and divide by the square root of 3 or multiply by the square root of 3. But if I multiply, it's going to make it bigger, right? I want to make it smaller. Smaller is the short side, okay? So I'm going to take that 15 and I'm going to divide him by the square root of 3. 15 divided by the square root of 3. Okay? But I don't ever like that square root of 3 on the bottom. So we're rationalizing. So we're going to take it times the square root of 3 over the square root of 3. So I'm taking it times 1. I'm just changing what it looks like, not changing the value of it. Okay? So on the bottom, when I take the square root of 3 times the square root of 3, it is, doesn't matter what it is. It doesn't matter what it is. It's the same thing, so it just pops out, right? Square root of 3 times the square root of 3 is 3. What's 15 times the square root of 3 on the top? 15 square roots of 3. But then, reduce. 15 and 3 will reduce, and that is 5 square roots of 3, right? Okay. So this is 5 square roots of 3, right? Okay, do you remember before when we had the 12 and we were trying to find the 1 side and I said you take it, you like split it in half and then you attach the square root of 3? Now you're going to divide it by 3 and attach the square root of 3, right? Like that's a little trend there. Okay, now this side is double what that number is. So this is 10 square roots of 3. Does that make sense? Yeah? Yeah? Okay, so that's how you work through those, right? There in that relationship. So I have 15, 5 square roots of 3, and 10 square roots of 3. That's what those are, right? Okay? All right, we're going to skip the back side, but we're going to do a homework problem together, just so we get one more example of a 30, 60, 90. Okay? Go to your homework assignment, and on skills practice, we're going to do odds. Skills practice will do odds. Skills practice will do odds. And the other side we're going to do evens. Skills practice is odds, the other side is evens. Okay, we're going to do number 7 on skills practice together. 7 we'll do together. Okay, so 7 on skills practice is the one with the 11. We have a 30, 60, 90, right? Okay, so which side is my 1 side?
The 11.
The 11, right? This is my 1 side. Which side is my 2 side?
The
Y.
X.
Or X.
X, which side is my square root of 3 side?
Y.
The bottom side, right? Or the Y, I guess, right? All right, so I have 11 is here. What will X be? Double that, right?
Yeah.
Double that. So that is
22.
22, right? Did you say that, Libby? I didn't hear. Sorry, I was talking at the same time you were. So 22. What about Y?
Multiply by square.
You just take this guy and multiply him by the square root of 3. What's 11 times the square root of 3?
11 square.
Just 11 square roots of 3. That's what he will be, right? That's the relationship between those guys, okay? All right, the square root of 3, don't make it a decimal, right?
Right.
Don't make it a decimal. So that's just kind of like shortcuts, right? You could use the Pythagorean theorem to figure some of these out, but it will give you the decimal, and this way is faster. Anytime they give you a 30, 60, 90, you can do this. 1, 2, square root of 3. 45, 45, 90 is 1, 1, square root of 2. Okay, good? Some of these end up being kind of weird, but it's okay. All right, there you go. Good? Happy with that? All right, goodbye, Evan.